I want to find r and theta. So I'm getting r is root 2, and then I'm having cos theta is 1 by root 2 and sin theta is minus 1 by root 2. How did I get that? Because I'm using this. Cos theta is x by r, and sin theta is also x by r. So using this, I am getting these two values, 1 by root 2 and negative 1 by root 2. Then I can check that theta is minus pi by 4 is satisfying. It is satisfying both these conditions for cos and for sine. But minus pi by 4 is not a principal solution. Then how to find a principal solution? How to find principal solution? What you can do is, you can put this minus pi by 4. Let's see for sine. For sine, what is the general solution? Sine theta is equals to, let's say, sine of minus pi by 4. Then keep in mind, general solution has all the solutions. So general solution also has the principal solution. So if you are finding one solution, now for example minus pi by 4, you can put this solution inside the general solution and then try to find the principal solution. So I'll write down theta is n pi plus minus 1 raised to n minus pi by 4. So this is our general solution. Now you will try to find out principal solution. So how to find principal solution, I told in class. What you will do is, you will put n values. You can say n is equals to 0, n is equals to 1, all integers, right? Because n is element of integer. So I can put n is equals to, if I put n equals to 0, then I'm just going to get minus pi by 4. Because this will become 0 and minus 1 raised to 0 is 1 only. So let's say I'm putting n is equals to 1. So theta will become pi plus minus 1 raised to 1. This will be minus pi by 4. So what will this be? Theta is equals to pi minus pi by 4. So this will be equal to, theta is equals to, this is 3 pi by 4. Okay, so 3 pi by 4. Now 3 pi by 4, is this a principal solution? Is this a principal solution? Can you check if it is a principal solution? You will see sine of 3 pi by 4. What is sine of 3 pi by 4? Sorry, there's one mistake that has happened over here. So this is positive, right? Because this is minus 1 raised to 1, which is minus 1 multiplied with minus, this becomes positive. So this is actually 5 pi by 4, right? It's not 3 pi by 4, it will become 5 pi by 4. So 5 pi by 4, is this a principal solution? So if you want 5 pi by 4 to be a principal solution, it should satisfy this, that it should be less than 2 pi and it should be greater than or equal to 0. So does it satisfy this? What you can do is, you can just divide 5 with 4. What is this? 4 1s are 4. This is 10.2. So 20. So this is 1.25. So 1.25. So I can say that 5 pi by 4 is nothing but 1.25 pi. So clearly this is greater than 0 and it is less than 2 pi. So that means 5 pi by 4 is a principal solution. Okay, now what you will do is, now this should satisfy this, that is cos theta is 1 by root 2, and it should also satisfy sin theta is equals to minus 1 by root 2. It should satisfy both these conditions. Is it satisfying? That is the question now. Is it satisfying both these conditions? Now cos of, what will this be? 5 pi by 4. This is nothing but cos of pi plus pi by 4. But we know cos of pi plus pi by 4 is nothing but negative cos of pi by 4. You can use cos a plus b expansion formula. You can try to find that, and this will be negative 1 by root 2. So it will not satisfy the first condition. It will satisfy the second condition, but it will not satisfy the first condition. So 5 pi by 4, even though it's a principal solution, I cannot take it. So n is equals to 1. I took n is equals to 1, right? I took n is equals to 1, then I got 5 pi by 4, but it is not working. So now I will take n is equals to 2 and write down again over here. So n is equals to 1 is not working. I have our theta is equals to n pi plus minus 1 raised to n minus pi by 4. Okay, then I'll take n is equals to 2. So n is equals to 2, I'm having theta is equals to 2 pi plus minus 1 squared minus pi by 4. This is 2 pi minus, because minus 1 squared is positive 1. So 1 into minus pi by 4 is just minus pi by 4. Okay. So this will be 2 pi minus pi by 4. So this is obviously less than 2 pi. Because 2 pi minus pi by 4. Na? So from 2 pi you are removing something. So it is less than 2 pi. But it is greater than 0. Because 2 pi minus pi by 4 is a positive number. So it's greater than 0. So 2 pi minus pi by 4 is indeed a principal solution. So I can 2 pi minus pi by 4, that can be simplified to 7 pi by 4. Now can I check? I have to check that does it satisfy this? Cos of theta is 1 by root 2 and sin theta is minus 1 by. It will satisfy this because from I'm for sine only I'm solving, na? For sine only I'm getting general solution. It will satisfy this. I have to check if it is satisfying cos. So cos of 7 pi by 4, that is nothing but 2 pi minus pi by 4, and this you can see it is cos of pi by 4. You can again use cos a minus b expansion formula. So this will be 1 by root 2. Cos a minus b means it is cos 2 pi cos pi by 4 plus sin 2 pi sin pi by 4. What is this? Cos 2 pi is 1 into cos pi by 4. Sin 2 pi is equal to 0. That is why you will have plus 0. And plus 0 means what it is? It is itself. So it is satisfying now. So you can see that 7 pi by 4 is satisfying cos theta is 1 by root 2. It is satisfying sin theta is equals to minus 1 by root 2. And it is also a principal solution. That is why now finally I have solved it. That is x is equals to 1, y is equals to minus 1, your r is root 2, and your theta will be 7 pi by 4. So I have converted my Cartesian coordinate, I have converted to polar coordinates. So my polar coordinates are r is root 2, theta is 7 pi by 4. So my 1 comma minus 1 has been converted to root 2 comma 7 pi by 4. The conversion formulas, if you want, I'll write down again. This is x, r sin theta is y, and r is root of x square plus y square. So your theta should always be a principal solution, and that principal solution should satisfy both the condition, that is cos theta should be equal to x by r and your sin theta should be equal to, we are using both these formulas, sin theta should be y by r. That theta should satisfy both these equations. So first of all it should be principal, after that it should satisfy both. Now how to find I have already told you. You either take for cos or you take for sin. Okay, after that you put in, suppose if it is not a principal solution, you put it in the general solution. From general solution you can get many principal solutions. Once you get the principal solutions, go on testing them if it is satisfying both for cos and sin, and then you can get the value. Now keep in mind, we wrote down the general solution for sine theta is equals to minus 1 by root 2. So what did we do? We found this sine of minus pi by 4 is minus 1 by root 2. You take minus minus. So we wrote this, that general solution is theta is equals to n pi plus minus 1 raised to n minus pi by 4. We wrote this because this is for this sine theta is equals to sine alpha. Sine alpha is minus pi by 4. It looks like this, no? But keep in mind, for general solution, standard way of writing, you will not write minus pi by 4 over here. You will write a principal solution over there. That is why the standard way of writing general solution is minus 1 raised to n. Instead of minus pi by 4, what I can write? I can write 5 pi by 4 or I can write 7 pi by 4. Because these are the two principal solutions we found out earlier, no? From this only we found out the previous two principal solutions. So instead of writing minus pi by 4, I can write down 5 pi by 4 or I can write down 7 pi by 4. That is the standard way of writing general solution. Because in general solution, whatever alpha angle you are writing, it should be a principal value. Okay. So that is your general solution, your principal solution, and conversion of Cartesian to polar coordinates. All of that is done. After that, you study sine rule. Sine rule. We will first study sine rule. Sine rule is very straightforward. Let's say you have your triangle with your vertices A, B, C. Opposite to the vertices, you have your sides. Small a, this will be small c, small c. After that, what you do is you drop your perpendicular. Let's say this perpendicular is perpendicular means making 90 degrees. Let's say this perpendicular is h. Okay. Now what is sine of c? What is sine of c? This is your c angle. Sine of c is opposite upon hypotenuse, right? So h upon b. And then what is sine of b? Because this is 90, then this also is 90. What is sine of b? Sine of b is h upon c. Now from the first equation, can I say that h is equals to b sine c? And from the second equation, I'll have h is equals to c. Keep in mind, angles are capital and the sides are small letters. So h is equals to this and h also is equals to this. From this, can I say that b sine c should be equal to c sine b? And then from this, I'll get sine c by c is equals to sine b by b. And then similarly, you can also get sine a by a. How can you get that? You have to drop a perpendicular on this. And then this is 90, then this is 90. Then you try to find what is sine of a. And similarly, so this is your sine rule. Sine rule. And how is this related to, we studied the proof also for this in the class. That you have your triangle, okay, and then you have your center of the circle, that is circumscribing. Circumscribing means a circle that is touching all the vertices of the triangle. After that, you take one of the vertex and which goes through the center of the circle. So this hole is your diameter, right? Because this is going through the center of the circle. So that is your diameter. From one end of the circle to the other end, going through the center means it is the diameter. And then what you do, you join this point to this vertex. So this vertex is A, this vertex is, let's say, B, this vertex is C. Center is always called as O, origin or O. Then let this point be P. Now properties of circle will tell you two things. The two things are that this full angle, that is angle ABP, that is 90 degrees. Another thing that you will know is from circle property that angle C should be equal to angle P. Okay, and then this I told you is the diameter. Diameter is 2 times radius of the circle. So we know that AP is equals to 2 times radius, because what is diameter? Diameter is 2 times radius. Okay, so what is sine of P? Sine of P is just going to be opposite, which is AB, upon hypotenuse, which is AP. But what is AB? AB is side opposite to angle C, no? Side opposite to angle C is small c. And what is AP? AP is, we have written AP is 2R. And we have also written that angle P and angle C are same. So instead of P, I can say this is C. And this is small c upon 2R. And then I get sine C upon C is 1 by 2R. But what is sine C upon C? See, we have proved over here. Sine C upon C is equals to sine B upon B is equals to sine A upon A. So that is your whole. So you can write down over here. Sine A upon A is equals to sine B upon B is equals to sine C upon C is equals to 1 by. And this R is radius of circle circumscribing the triangle. Circumscribing means touching the vertices of the triangle. 3 vertices are there. Okay, so that is your sine rule. After that you have your cosine rule. Cosine rule is again simple. You have your 3 sides. Okay, so this is your A, this is your B, this is your C, this small c, small b, this is your small a. Now what I will do, I will say this distance is x. Now this full distance is a. So this remaining distance will be a minus x, right? Because full distance is a and this small distance is x. So what is the remaining distance? Remaining distance is a minus x. And let's say this is height h, perpendicular 90 degrees. So use Pythagoras theorem in this is your triangle 1, this is your triangle 2. In triangle 1, if I am using Pythagoras theorem, I will have a minus x squared plus h squared is equals to c squared. Okay, and then in triangle 2, if I am using Pythagoras theorem, I will have h squared plus x squared is equals to b squared. Now what I will do, from this second equation I can have that h squared is b squared minus x squared. So now I will put this in first equation. Then I will have a minus x squared plus b squared minus x squared is equals to c squared. Then what do I get? This is a squared minus 2ax plus x squared plus b squared minus x squared is equals to c squared. I have just expanded a plus a minus b squared formula. So plus x squared minus x squared, this gets cancelled. Then I'm having a squared plus b squared minus 2ax is equals to c squared. Now I have to get rid of this x because x is something that I have taken. In question there is no x. In question there will only be ABC and your small abc. Angles capital ABC and small abc. What is x now? Now look at this triangle, second triangle. Look at second triangle. And what is cos of C? Cos of C is going to be adjacent upon hypotenuse. So your x is going to be equal to b cos C. So this will be a squared plus b squared minus 2ab cos C is equals to c squared. So that is your cosine rule. Now here the triangle that I have taken, starting triangle, the big main triangle, it is acute triangle. Acute triangle means all angles are acute. Acute means what? Less than 90, right? I can also have obtuse triangle if I have if my diagram is something like this. This is my A, this is my B, this is C. This will be small a, this will be small c, this will be small b. How will I prove cosine rule in this situation? In this situation, I can extend this. And I can say this is x and this whole is a plus x, right? because this much distance is a, this much distance is x, whole distance is a plus x, and this is my 90 degrees, and let's say this point is P, this height is h, and my starting triangle will be APB. Look at triangle APB. So that will be an exercise for you. For this triangle, how will you prove cosine rule? How will you prove cosine rule for this triangle? If you look at triangle APB and use Pythagoras theorem, you will have h squared plus x squared is equals to b squared. That is h squared plus x squared is equals to b squared in triangle APB. And then after that in triangle, sorry, not in triangle APB, this is triangle APC. I mean APC. This first triangle, triangle APC, small triangle. So in small triangle you are having h squared plus x squared is equals to b squared. Then look at the big triangle. Big triangle is your triangle APB. That is the biggest triangle. In that triangle you will have h squared, Pythagoras theorem will be h squared plus a plus x squared is equals to c squared. From here you can have h squared is b squared minus x squared, and then again you can substitute over here and then expand this. This will be plus 2ax, correct, is equals to c squared. And then this x and x, this get cancelled, so you're having a squared plus b squared plus 2ax is equals to c squared. Now how will you find x in this situation? In this situation, how will you find x? Okay, so now this is angle C. This is angle C, correct? What is this angle? What is this angle? This angle will be 180 degree minus C, right? Because this is supplementary angles, right? Straight line and then that is C, so that angle will be 180 degree minus C. So what is the cos of that angle? The arrow that I am pointing, that is cos of 180 degree minus C. What is the cos of this angle? Cos of this angle is nothing but adjacent upon hypotenuse, right? That is x divided by b. But what is cos of 180 minus c? Cos of 180 minus c is minus cos c. That is nothing but cos of pi minus c, right? That is what we studied earlier. That is how you make a cos negative cos of c. So negative cos of c is x divided by b. So x is equals to minus b times cos c. So again substituting over here, you will have a square plus b square minus 2ab cos c is equals to c square. So that is how you prove cosine rule for obtuse triangle. First we proved for acute triangle, now this is obtuse. Obtuse means why? Because see this angle C. Angle C is more than 90. It is good. This is your 90 degree line. So your angle C is going beyond 90. So for obtuse triangle also we proved. So other two types of cosine rule, what will we have? For a square plus b square minus 2ab cos c is c square. Then can I say b square plus c square? So here ab, then here also ab. So here I should have bc. Then here c and c, then here I should have a and a square. What about a square plus c square? So here ac, then here also I should have ac. Then here if I have b, then here I should have b square. So these are the other two formulas of cosine rule. Finally, you have your projection rule. You have your projection rule. Projection rule is straightforward. Let's say you have your triangle again, ABC. Drop your perpendicular. This side is A, this side is B, this side is C. What is, let's say this side is X, so this side will be A minus X. Okay, so what is cos of C? Cos of C is going to be X upon b, correct? So b cos c is going to be x. Similarly, what is cos of b? Cos of b is going to be a, this is 90 by the way, this is 90, a minus x divided by small c. So c times cos b is going to be a minus x. This is your first equation, this is your second equation. Now add both the equations, you will have b cos c plus c cos b is equals to a plus a minus x. So can I just say it is equal to a? So it is just equal to a. So similarly, from this pattern, I can say that a cos b plus b cos a is equals to what? C. After that, can I say a cos c plus c cos a is equals to b? Just looking at this pattern. So here I am having b and c, c, b and then a. Similarly, a, b, b, a and then c, a, c, c, a and then c. Just looking at the pattern, I am getting the other two equations. So that these are the equations of your projection rule. So till now what have we studied? We have just revised your trigonometric equation, your general solution, principal solution. While writing general solution, make sure that alpha value, it should be a principal value. Okay, that is the standard way to write your general solution. And then never forget to write an element of integer for your general solution. And then after that we studied Cartesian to polar, polar to Cartesian conversion. And after that we have these three rules: sine rule, cosine rule and projection rule. We will end this video over here. Thank you for watching.